So connect A to D, so all the way up this line. And I'm going to make it bright red. And then I'm going to use 3 different colors to do along the bottom. A to F. Then I'm going to do A to G. Now please notice what I am doing here. And then I'm going to do A all the way out to H. Now please notice that the way I have drawn this, and this is for teaching purposes, I've drawn 3 lines. But it would be the same blue line all the way out. Is everybody with me? Okay, you don't have to. This is for teaching purposes. Okay? If you guys just do 1 line all the way out here and all the way up here, you'll be fine. Everybody cool? Yes. Okay. So now, just like we did yesterday, let's compare the ratios of the line segments. So B to F is right here, yes? How long is B to F? Just count. B to F. 1, 2, 3. Okay. 3. And how long is A to F? 4. So the ratio is 3 to 4, yes? Everybody remembers those ratios from like grade 3, right? That's how you learn to write ratios in grade 3. How many boys in the class, how many girls in the class? And that was the one every teacher did, yeah? Okay. Grade 10 and from grade 3, you already should have learned there's 2 other ways to write ratios. One of them is as a fraction. 3 over 4, right? And what's the other thing we can do with fractions? Emma. Oh, yeah, you could put it in words. 3 to 4. Yes, you could actually write it that way as well. What mathematically can we do with a fraction? Daniel. Decimal. And what is 3/4 as a decimal? 0.75. Is everybody cool with that? So that means in this triangle right here that I'm coloring green, I have angle A here, right? And angle A is in that green triangle, and when I compare those 2 sides, I get 0.75. Everybody cool with that? All right. Now, I want you to do C to G down here. What's that? One, 2, 3, 4, 5, 6, 7, 8. Yeah? Right? I think this is the drawing I screwed up, though. Yeah, C's got to go up 1 more. C is right up there. I drew the line too low. C's 1 more up. There we go. So C to G is 9. What's A to G? 12. 9 over 12. Hey, wait a minute. What's that as a decimal? 0.75. Now I've got this blue triangle, yes? Now that blue triangle is made up of this green triangle plus this part, right? What do you notice is common to both triangles? They both have a right angle. Excellent. But they're not the same right angle, are they? Because one of them is over here at F and one of them is over here at G. So that's a common characteristic, absolutely, Jazri, but it is not something shared by both triangles. So can anybody else tell me something that is shared by both triangles? I'll give you a hint. It's already colored in on my screen. Angle A. Please notice angle A is in the little green triangle, and that exact same angle is in the big blue triangle, right? Now you guys are smart kids. What's going to happen when I go D to H? And I compare it to A to H. You already know this from yesterday's work. Those are similar triangles, aren't they? So doesn't that mean all the fractions are equal? So what's DH going to be? Without even counting, what's its decimal going to be? 0.75, isn't it? Now, if we count it, we see that this is 15 and this is 20. Is everybody cool? All right, now, out here in the yellow triangle, what is common between all three? Angle A, right? Did angle A get any bigger or smaller when I made the triangles bigger or smaller? Did angle A change? Did it? No. When we took a comparison of this side and this side, this side and this side, this side and this side, did it ever change? No. So what would you say would the comparison be if I made this orange line go all the way over to here and I made that red line go up to the ceiling? What would the decimal be if we measured it? 0.75. What wouldn't change? The angle of A. Does everybody understand that? So what's a general statement we can make about this situation? Not the angle. It's not the angle. The ratio. Right? So, I got to get a better pen. If we compare, what sides of the triangle are that? Are those legs or hypotenuses that we're comparing? They're the legs, right? If we compare legs of right angle triangles, we see that leg length does not affect the ratio. The ratios. Does everybody see that? Does everybody understand what I said there? Doesn't matter how far I draw those lines, if I compare the two legs, I'm going to get that same decimal. Now, question is, what if I drew this triangle with a brown line? Would that angle give me 0.75? No, because now the sides are different. Does everybody understand? What if I carried on like this? Would that brown angle have the same decimal if I compared this one and this one to the bottom? Yes. Everybody cool? Okay. That is what we call the tangent ratio. Know that word. Live it, love it. And it holds true for all right angle triangles. Everybody cool? All right. So now we're going to do some calculator work. I need everybody to get their calculator out and be looking at the screen. You must have a calculator to do this unit. It is impossible to do without a calculator. If you are still using your phone, that's fine until the test. I will not let you use your phone. So if you show up here without a calculator on test day, you don't write the test, which means what mark do you get? Excellent. Everybody look at their calculator. Now my calculator's a bad one because it's not good because it doesn't show me. But all of you look very closely at your calculator screen and look on it and see if you can see the letter D or the word D-E-G. Does everybody have it? Somewhere on your screen. If you don't have the letter D or the word D-E-G, you probably have an R or rad or a G and grad. How many people are in one of the red boats? Okay. You need to look on your calculator for the button that says DRG, and it might have an arrow. Push that button until your calculator says D or DEG. Huh? Does your calculator show D? Bring it here. It's the worst day of trig when everybody who has different calculators has to get it sorted out. Yours says DEG right there, DEG. Just like I said, DEG. Okay. Does everybody have D or DEG showing on their calculator screen? Going once, going twice. Yes, Jazri. You have my kind of calculator, don't you? So stop, push mode, and use the arrows to go down until you highlight the word degree. I did say 2 steps. That's a long ways. You don't have my calculator. And your calculator says grad, so you find the DRG button right there and press it till it says DEG.
The DEG.
No. I didn't say that. I said your screen would say DEG and you must push the DRG button.
Okay. Thank you.
Is everybody on degree? Okay, that's the first hurdle out of the way. The next hurdle out of the way. If you push the button that says tan, all of you should have a button that says tan. How many of you get the word tan on your screen? Put your hand up. If you push tan and you see the word tan, you have what I call a forwards calculator. So, when I ask you to do tan 35 on your calculator, if you've got a forwards one, you will push the button tan 35, close the brackets if you need to, and then equals. Everybody who has a forward calculator do that. If you have a calculator that doesn't show the word tan, then you need to reverse everything because you, my friend, have a backwards calculator. You have to push the number first, 35, tan, and you will not need to push equals. Now, everybody do that and you will get a decimal. And your decimal should be 0.700 blah, 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 blah. Can everybody make their machine do that? Yes? Who said no? Help her out, Carlin. Everybody cool? Okay, now, that decimal, 0.700, is 700 over 1,000, isn't it? Right? Isn't that a ratio? Yes, Carla. Then she is not on D mode or degree mode. She didn't push the DRG button like I told her to. Come here. Everybody agrees that this is that decimal as a fraction, yes? Everyone agrees? Which means if I drew the triangle that we just drew up above, what you all listened to me and said you understood. Yes. Everybody? Okay. So that triangle, if this was angle A down here, where would the 700 go? Would it be the vertical leg or the horizontal leg? It's right on your screen in front of you. Which one was in the numerator spot? The vertical or the horizontal? The vertical. So this would be the vertical leg, right? There would be the 700 and there would be the 1,000. Is everybody cool with that? Okay. Now do that twice more. Get me this decimal. What would it be? So I go, did you get it to work, Emmeline? Yeah. Okay. What was it? Okay. So tan of 15 gets me what? To 3 decimal places. 0.268, right? We'd round that. So tan of 15 is 0.268, yes? So what would its triangle look like? .268 is 268 over 1,000, yes? So where would the 268 be? 268, 1,000. Everybody cool? Yes. Okay. What's 45? 1. So that would be 1 over 1 or 1,000 over 1,000. What would the triangle look like? It would be the same on both. Is everybody cool with that? Yeah. All right. Now, I want you to look at something. When I put A down here, the 700 was across from it, yes? What's the word we use for across now? Opposite. When I put A here, I went opposite, yes? Don't write this down. We're going to do this later again, but use your brain. What if it's so very anticlimactic when my computer stops working? What if I put A up there and I have 268 over 1,000? What would that triangle look like? Don't write it down, just use your brain. When A was down here, it was 268 over 1,000. But now A is up here. So where does the 268 go? On the bottom. 268 over 1,000. Does everybody understand that? Okay. What I am trying to say there is this tangent ratio that we talked about, and there's blank space left under here, is always the opposite side divided by this side gets a special name too, the adjacent side. We know that opposite means across. You guys are smart kids. If opposite is across and the long line is the hypotenuse, then the adjacent must be what? The last leg left, right? The one that's right beside your angle. So opposites across, there's opposite, this is hypotenuse, so this must be adjacent. Is everybody with me? Now, without writing it down, what happens over here with the blue triangle? What has changed? The A has moved, yes? Did the hypotenuse move? It's still the hypotenuse, but now what's this side? This is now the opposite. And what's this side? This is now the adjacent. Does everybody understand that? Okay? And that makes sense, right? Right now, you're all looking at me. If I move to that end of the room and you keep your eyes up here, does your view change? Yeah, because I'm not here anymore. Just like this. If I move my A up here, my view of the triangle changes. Is everybody cool? Okay. Now we're going to do something a little different. Tan of 0.75. I already have the decimal, don't I? Right? That decimal is 75 over 100, isn't it? So if angle A is here, where's the 75? Vertical or horizontal? Vertical. And that's the 100, yes? Does these two numbers tell me this angle? No, but my calculator can do it because my calculator knows what every angle is when I divide those two. So on your calculator, we are going to do this. Now remember, if you've got a backwards calculator, you've got to reverse this. If you've got a forward calculator, you're going to push shift or second. So on my calculator, I push second, and then I'm going to push tan. And it makes this little -1 sign. So shift, tan, on my calculator gives me tan -1. Tan -1 is an angle. So in this case, I'm looking for an angle. So I push shift tan. What do you think I punch into my calculator now? 0.75. Close the brackets, and then equals. So that angle is 37 degrees. Does everybody understand? Now, what if you have a backwards calculator? How do you do it? You just reverse the order. You do 0.75 shift tan. So if you've got a backwards calculator, you're going to go 0.75 shift tan. And you're going to get 37 degrees. Now, you guys are smart kids. Didn't we just do a triangle that had 0.75? So now you can tell me how big is angle A? 37 degrees. If I change that triangle, will I change the decimal? If I change the decimal, do I change the angle? Good. You guys are brilliant. You understand trig. If you understand that, you know everything. Okay? I don't want you to do B. B's a pain. Get rid of the negative. Do tan B of 1.23. And tell me what you get. 51, right? 51 what? Degrees, right? Okay. And then do tan C. What's that one? 68. Can everybody make their calculator do what they need it to do? Yes? Okay, now, remember, what are the two things I'm comparing? What are the two things I compare in order to get the tangent ratio? Remember, the tangent ratio is the decimal or the fraction. How do I get the decimal or fraction? What do I compare? Other way around. Opposite compares to the adjacent. How do I know what's opposite? Is it beside or across? Across. Across from what, Jashandeep? Not necessarily the A, but the angle you're using. Understand? Across from your angle. Is everybody cool with that? All right, so let's see. I have 3 angles in this triangle, right? We are never going to be dealing with angle C because it's the 90 degree. We're only going to deal with A and B. So looking at angle A, that means I'm up here, right? So that's my view of the triangle, yes? So what is the tangent ratio of A? Don't give me a decimal, just tell me the ratio. Talk to your neighbor if you need to. You've got it right here. What is it? He waited patiently. What? So what's opposite to me when I'm up there? 12. Over what? 5. Now, what is that as a decimal? Now give it to me as a decimal. 2.5, right? 4. Duh. Now, if I move down to here, slide to there, am I in a new spot? Yeah. Does my view of the triangle change? So what then is tan B? 5 over 12, which gives me what is the decimal? 0.41. Exactly? 3 decimals. Great. Is everybody cool with that? Now, I have the decimals. Do I have the angles? No. What finds me angles? Angles need what from your calculator? They need shift tan. Right? So what is angle A? I need to push shift, tan, and then I can use the decimal, or I could do bracket 12 divided by 5, couldn't I? And then for B, it would be shift, tan, I could use the decimal, or 5 divided by 12 in brackets. Now, tell me what those angles are. Shift, tan, shift, tan, 12 divided by 5, close brackets. What's A? 60. We don't measure degrees in decimals. We round it off to the nearest degree. 67 degrees. What's B? And B is 23 degrees. Is everybody cool? Yes. Now, please read what this says. Write what you had to type. So on your machine, the buttons you push, if your machine has a S or a shift instead of second, you're going to write shift. So for me here, I have to push second, tan. I get the first bracket from my calculator, right? Second, tan gets me my first bracket. Then I push 1, 2, divided by 5, close bracket, equals. That's what I push. You write down what you push. Haley.
How do you do it on a backwards calculator?
You're going to reverse it. Everything reverses in order. So for you, Haley, you're going to have to do the number first. You're going to go bracket, I'm going to do yours in blue. If you've got a backwards calculator, you got to do the brackets first. You would go, if you're backwards, you're going to go bracket 12 divided by 5 bracket shift tan. And that should work. You shouldn't even need to push equals. Did it? Everybody was able to get 67? Yeah. Everybody can make their calculator work forwards or backwards, whatever they have. Yeah. Going once, going twice, going thrice? Okay. Now, guys, weird, right? Because your calculator's doing stuff that is like, ugh. But here's all you have to understand. Your calculator knows every fraction for every degree. It already knows that. Okay? Because it's just a division. Wait. Your job is to finish those 3 triangles up to the end of 55. Just try. We'll finish it tomorrow. Thank you guys once again. I apologize for yesterday. You'll have your marks up on Check My Mark later today.